Well, hello everyone. My name is Giles Knight. I work as a research assistant in the Department of Geography and Planning at UWA, and today I'd like to talk to you about urban tree canopy cover, and in particular, some of the recent research we've conducted that led to the creation of an online geospatial dashboard that allows you to visualize tree canopy across the Perth, Melbourne and Sydney metropolitan regions. So to begin, I want to briefly touch on the importance trees play within the built environment. Urban tree canopy cover is one of the best defences we have against rising temperatures in our cities and suburbs. Now this is of course being driven by climate change, but it's exacerbated by something known as the urban heat island effect, which is where an overabundance of surfaces such as concrete and asphalt trap and retain heat and elevate those temperatures further. If you combine this with a net decline in tree canopy due to growing urban density and the expansion of suburban sprawl, you can create significant ramifications for both public health and livelihoods. So our research set out to benchmark the current state of tree canopy across Perth, Melbourne and Sydney. We wanted to quantify how much we have and where it's distributed. We also asked the question, what land uses does tree canopy reside on? Is it mostly on public land, where local government policy could be better utilised to target its conservation, or is it on private land, where much of that decision making is in the hands of the landowner? So to answer these questions, we sourced data from the CSIRO's Urban Monitor dataset. This is a raster data product that covers the spatial extent of Perth, Melbourne and Sydney, and it identifies the presence of vegetation. But what's unique about Urban Monitor is that it's captured by aerial photography from multiple angles, and that allows us to compute a height property and classify identified vegetation into categories such as tree, shrub and grass. We can then summarize this data within low-level land use boundaries and aggregate that to a suburb reporting level. Now for 3 metropolitan regions, this totals to more than 1,700 suburbs. So to distill this data down and to make it accessible to the public, we decided to build a dashboard. And here's what we made. This is the Perth page. On the left-hand side, we've got a leaflet web map that allows you to explore the spatial variability of tree canopy. And then when you click on a suburb, on the right, a series of bar charts update to answer some of our land use questions. Now we've built all this using open source tools, namely on a platform called Shiny. And what I'd like to show for you now is a small demonstration of some of the interesting information we can draw from this by doing a comparison of 2 suburbs in the Perth region. The first one we'll look at is Nedlands, a place well known for its leafy green streets, and the second one is this suburb down here in Mandurah called Meadow Springs. The reason I've selected these 2 is that they're both established residential suburbs with similar densities, but remarkable differences in the amount of tree canopy and the land uses that hold it. So let's start with Nedlands. What I've done here is I've just blown up one of those bar charts from the right-hand side. This particular one is the vegetation cover of the suburb. And what you'll see is that in Netherlands we're recording 22% tree canopy cover. If we look at the raw land uses that make up the suburb in this top bar chart here, you'll see 55% of the land is zoned as residential and 9% as parkland. Now the bar chart below it looks quite similar, but what that is the distribution of just the tree canopy by land use. And you'll see 55% of the tree canopy resides on residential land and 8% resides on parkland. Now the reason these are so similar is that in Netherlands, tree canopy is proportionally distributed by land use. And I want you to keep that in mind as we now take a look at Meadow Springs. Here we have 11% tree canopy. That's half what we had in Netherlands. If we look at the land uses, it's 47% residential, somewhat similar, and a slightly larger 24% parkland. But take a look at how that tree canopy is distributed. Despite residential land accounting for nearly half of the suburb's area, it holds just 1/5 of the tree canopy. Whereas parkland, which made up nearly 1/4 of the suburb's area, holds almost 60%. So we can start to conclude here that tree canopy is not proportionally distributed by land use, and in fact it's significantly underutilised on residential land. It's suburbs like this that lack tree canopy on the land uses that need it most that are more likely to experience exacerbated temperatures without the intervention of appropriate policy and urban greening measures. That's all I've got time to share. If you want to check out your own suburb, head on over to nesturban.edu.au where you can check out this dashboard yourself and read our report on the key findings. Thanks for listening.